This is a SediMeter SM3B with a cleaner. The cleaning shuttle is not mounted here. Up here in the top is the motor that drives the reel that lifts and lowers the cleaner. Inside here is the battery, and then we have the same electronics as in the SM3A version. The connector on this one is in the bottom and not in the top. Now here, what we see here is the tube for calibrating it. We have one with distilled water and another one with Formacin 4000. There is one inside now that's been sitting here for almost 2 days, measuring once every minute. And here we can see the result. Alright, like that. Changing the contrast. Now we can see that it actually, things are happening inside this Formacin when it's settling. Towards the very end, we see clear water reaching the detector number 36 and a high concentration towards the bottom. In the middle graph here, we see, you can see over here it says level centimeter, thick red line, and FBU top 6, thick blue line. And then we have the centimeter red line and FBU blue line. These two come from the instrument. These two are calculated in the software. So when we start out, the blue lines have the scale here on the right, 4000 FBU here. From 0 to 4500 here. And on the left side we have the bottom level. The red line goes on the left side, 0 to 36 centimeters. When it starts out, it's about 4000 FBU, and then it goes a bit up and down until we get here. Now, the thinner blue line drops down. That's the detector that is located much higher than the others. Put the instrument here, you'll see that we have detectors up to number 36 here, and then 11 centimeters higher up there is another one right there that is used to measure the turbidity in the instrument. That's the thinner blue line that drops down. So the top of the SediMeter cloud passes below that here. Above that the water is almost clear, not completely because it still has a few hundred FBU, but almost clear. The thicker blue line is the average of detectors number 30 to 35, or the 31st to 36th sensor. And it hasn't yet reached, here it's starting to reach that. Right here at the end, we start to see the clearer water coming down to detector number 36. And it's starting to accumulate by the bottom also. The bottom here on this instrument is like 20 centimeters above the bottom of the tube because the connector and the blind plug is mounted. Here we can set the grayscale. Reset sets it to predefined scale from 0 to 30,000 FBU with 15,000 as the intermediate value. Adjust it to what's actually in the display from 0 to the little bit above the maximum value, and puts this level here, the bottom definition also, at 25%. Here is a switch for selecting if the instrument is inside a holder tube or not. If it's inside a holder tube, it will change the calculated values to account for the reflection in the tube. The bottom definition can be varied manually by moving this slide, or by moving this, or even by typing in here. The bottom definition is used to calculate the bottom level with the thicker line here. Let's see if we can get an effect if we change it here. I'll put it very high and see. it will not change it because down here the bottom definition is set to be the bottom is set to be calculated automatically, the method, and then the instrument itself does the same calculation as up there. If we want to do it manually, we can set it at one of the manual methods. The difference between these methods is how much it interpolates between the detectors. Here is a linear interpolation, 1 harmonic sinus curve, 2 harmonics or 3 harmonics. So if we put it on 3 harmonics, here are the values. And then, as you see here, the red line starts, the thick red line now takes a different position than the thin red line, which comes from the instrument. And we can vary here the bottom definition, and when I pull that down, you see how the calculator bottom changes here. So you get one value from the instrument, and then you can play around with the values in the software to account for factors that you may be aware of and the instrument not. For instance, growth or something that ended up on top of one of the detectors. Another thing you can do here is you can actually ignore one OBS. Let's say you have one that has been covered by something. You can ignore that, and it will extrapolate between the ones above and below to calculate the value for that. Finally, you can manually input the value. By putting this on manually, you can here select which measurement and which value you want for that measurement. That's just an aesthetic cleanup. As soon as you put it back to auto, it will again recalculate everything and your manual changes will be lost. Alright, back up here. As I said, this one says the default grayscale, here it adjusts it, and this is for the bottom definition. There's one value here I want to mention, saturation voltage. Every measurement that has a higher voltage than that will be marked as yellow. The same if we have a value that's below this one, above this one, it will also be yellow. So it means that whatever we have there is not useful. It should not be taken into account. The maximum value saturation can be is 2.49 because the scale goes to 2.50. And usually the default, let's see what the default value is. If we right click the mouse, right click here, reinitialize to default value. This is the default, because above that value it's no longer linear relation. That's why that's put as the default. If we have more than one SediMeter connected in a network, here we can select which one we want to look at, and here we can select which data to show. The FPU is the one that's reported, but we can also show the voltage when it's on, because it measures with the light off and with the light on, the infrared light. And here are the values with the light on. And then we can show the ppm value. This is a value where you take the FPU value, the software takes the FPU value and converts it to sediment concentration in parts per million using these conversion constants. A is the linear factor and Q is the exponent. You have to determine these constants based on measurements of turbidity and sediment concentration from a sample that you dry away. The formula, again, we right click here to open the menu, and you see the description and tip. Here it gives you which formula is being used. Coefficient for converting FBU to ppm according to ppm equals A times FBU to the power of Q. Okay. You can also turn on help here. Show context help. Now, wherever you point your mouse, it will open the information here, and here you have the formula. So wherever you go with your mouse now, you will get the help. We'll turn that off because it tends to get kind of annoying once you know what you're doing. All right, and if you want to store the data that are coming in, you have to select the file here, give a file name, accept, now I'll do cancel, and then you turn it on and off with this button here. So when this one is lit and there's a file name here, it will save every measurement to file. And we turn it off again with this. Done. Now to finish the measurements, you have to go to monitoring and deselect this. See, now it's deselected. And then wait for one more measurement to come in, and then you can go to file and close. It measures once every minute now, so it will take less than a minute for the window to close. And once it closes, obviously you go back to this window.